also on page 98 of your textbook. Actually, you can flip back a couple pages to the property chart that you copied down. That's very important because that's going to be the basis for, I said 98, huh? I meant 87. Page 87, you see that property chart? Many of you learned this already. A lot of what you learned in pre-algebra, you're going to see again in algebra. It's just going to be maybe a little bit harder. Not a lot. Let me turn myself down. And so, a lot of it is, what happened? A lot of it is going to be repetitious. So just, bear with us if you had it perfected last year and we're doing it again this year, just be patient. Okay? So if you look at the property chart for addition and subtraction, basically you already copied it down, so I'm not going to have you write anything on it. But basically it's just telling you that if you have two numbers that are already equal, like say 2 and the square root of 4, right? 2 and the square root of 4. What's the square root of 4? 2. So those are equal, right? So if I take those two numbers and I add or subtract any number, like 1, if I add 1 to both sides, do they stay equal? Yes. If I subtract 1 from both sides, do they stay equal? Yes. So that's all those properties are telling you. And we use those properties to solve, now I can't hear myself. We use those properties to solve equations. Okay? So the only way I know how to show you how to solve equations is to just solve equations. The more you practice it, the better you get at it. Okay? So turn to page 91. I'm going to do question number 11 for you. Okay, it says 27, and you can watch me do it, and then I'll give you time to copy it, but I want you to watch me first. They start off really easy. They always do. 27 plus n equals 46, so we're trying to figure out what n is. Okay? So there's many different ways to do this. I have a couple different methods. I'm going to try one with you. If I see you giving me the face, we'll try another one. Okay? Until we get one that works for you. Alright, so the first thing I'd like to look at is think of the variable as your target point. That's what you're trying to get to. So the first thing we need to do is establish our boundaries. Okay? This equal sign is your boundary. The equal sign separates the equation into two parts. Remember, the way that I'm showing you is just a way. Your teacher last year might have showed you another way. If you like it better and it's mathematically right, you can use it. It doesn't matter to me. As long as what you're doing is right and you can work with it, I'm happy. This is just a way. If you like this way, you can use it. If you don't, you can use another way. Alright, so your equal sign splits your equation in half. Okay? The key to remember is everything that's over here has to be over here for it to be an equation. Because an equation means both sides are equal. There you go. Okay? So, first thing, the variable's on the left side. So we're looking at the left side to see what we want to do. We don't care what's on the right side right now. We care about this variable, and it's on the left, so that's where you look. And over here, you have to ask yourself, this is the question I always ask myself when I'm solving equations. What did they do to the variable? What did they do to this variable? But you have to use operations. Tell me parentheses, exponents, multiplication, addition, subtraction, division. Tell me, what did they do with that variable? They added it to 27. Is this a positive or a negative 27? Positive. Good. Remember, that's important in algebra. So, in order to get rid of that 27, because we want to get rid of it. Does anybody know why we want to get rid of it? Bianca? Emerson?
To get the n by itself.
Good. We want to get the variable by itself. That's called isolating the variable. When you're in prison, if they put you in isolation, hopefully you don't know this. If they put you in isolation, that means they separate you from everybody else, put you in a little room by yourself. We want to isolate the variable, okay? So the opposite, you always do the opposite. That's how you get rid of stuff. You do the opposite. The opposite of plus is, notice I'm not pointing at this plus. Guess who does this plus go with? The n. So the opposite of plus is minus. But if I do it over here, I have to do it over here because it's an equation. And you draw your line. Okay? Now you make things happen. What's happening right here?
Cancel out.
Cancel out. Because 27 minus 27, 0. So it cancels out. Bring down the positive n. You don't have to write the plus if you want to. If it makes you happy, you can. And 46 minus 27 is 19. Once the variable is isolated, you're done. Okay? So n equals 19. Finish. Simple enough? Alright. It always starts off simple. See how I keep warning you? Alright. Let's do number 14. It says negative 5 plus a equals 21. Anybody remember what's the first thing I need to do? First thing, Emerson. Draw your lines. Set your boundaries. Okay? Divide your equation into two parts. Okay? Next thing I need to do, anybody remember? Ruben. Okay, but you got to tell me like a teacher. You can't tell me like a teacher? Okay, you were right though. Rufino.
You add 5?
Very good. Well, I was looking for this. You look for what they do to the variable. Okay? What did they do to the variable? See if you can get that. Now this is tricky. What did they